In the winter of 1943, German fighter pilots patrolling the skies over Berlin reported something previously unthinkable. American fighters, more than 600 miles from their bases in England, escorting bomber formations deep into the heart of the Reich. Those sleek silver fighters with distinctive red tails were not supposed to be there. It was mathematically, aeronautically, strategically impossible, until it wasn't. Within 6 months, the Luftwaffe would lose control of German airspace. Today, you will discover how American engineering genius transformed a mediocre fighter into the aircraft that shocked Germany's most experienced pilots and changed the course of World War II. By January 1944, the United States was facing a crisis in the air war over Europe. The flying fortress strategy was failing. Wave after wave of B-17 bombers, once thought impervious to fighter attack due to their defensive armament, were being shot down at catastrophic rates. The previous October, during the infamous Schweinfurt-Regensburg missions, the 8th Air Force lost 60 bombers in a single mission, and 2 weeks later, 77 more. That represented over a quarter of the attacking force, losses that were simply unsustainable. No Air Force could continue operations losing 25% of its aircraft and crews on each mission. The fundamental problem was simple, yet seemingly insurmountable. American fighters lacked the range to escort bombers all the way to targets deep inside Germany. The P-47 Thunderbolt, America's primary fighter at the time, could accompany bombers for only about 175 miles of their journey. Beyond that point, the bombers were on their own, easy prey for the Luftwaffe's experienced pilots in their nimble Messerschmitt 109s and Focke-Wulf 190s. American bombers were being slaughtered in what crews grimly called the slaughter box, the airspace over Germany where they had no fighter protection. The critical turning point, military analysts, politicians, and commanders were faced with an impossible choice. Abandon daylight bombing altogether, as the British had done, or continue suffering losses that would eventually break the back of American air power. The entire Allied strategy for defeating Nazi Germany hung in the balance. The concept of strategic bombing, striking at the industrial heart of the enemy to cripple its war machine, remained unproven. If America couldn't solve the escort fighter problem, the entire theory might collapse. General Henry Hap Arnold, commanding general of the U.S. Army Air Forces, refused to accept defeat. The bombers must go through, he insisted, in a now famous cable to his commanders in England. Find a way to protect them. The pressure was immense. President Roosevelt himself had committed American strategy to daylight precision bombing against the advice of the British, who had switched to night bombing after suffering devastating losses. The solution would come from a seemingly unlikely source, an aircraft that had been deemed inadequate when first introduced. Birth of a legend. The North American P-51 Mustang had an unusual genesis. In April 1940, the British Purchasing Commission approached North American Aviation with a proposal to build Curtiss P-40 fighters under license for the Royal Air Force. North American's president, Dutch Kindleberger, made a counter-offer that would change aviation history. We can design and build a better fighter than the P-40, and we can do it in less time. The British agreed with strict conditions. The new aircraft must be in production within 120 days, an almost impossible deadline by the standards of aircraft development. Working at a feverish pace, North American's engineering team, led by Edgar Schmood, designed and built the prototype NA-73X in just 102 days, one of the fastest development cycles in aviation history. The result was a sleek, innovative design that incorporated the latest aerodynamic research. The P-51 featured a revolutionary laminar flow wing, which dramatically reduced drag at high speeds. It employed a novel cooling system where radiators were positioned in an aerodynamically refined duct under the fuselage. Wind tunnel tests showed this arrangement not only minimized drag but actually produced a small amount of thrust from the heated air exiting the radiator, a phenomenon later called the Meredith effect. This ingenious cooling system represented a significant advancement over conventional designs. Most fighters of the era used radiators mounted in pods below the wings or in the nose, creating substantial drag. The Mustang system, by contrast, used a carefully designed duct that slowed incoming air to improve cooling efficiency while minimizing disruption to airflow. The heated air exiting the radiator actually accelerated, producing a small amount of jet thrust, an effect that became more pronounced at higher speeds. This seemingly minor design feature contributed significantly to the Mustang's exceptional performance. The prototype's construction also broke new ground. The Mustang was one of the first aircraft to have its fuselage mathematically designed using precise conic sections, resulting in exceptionally smooth surfaces with minimal drag. The airframe was divided into 5 main sections: forward, center, rear fuselage, and 2 wing halves, all fitted with wiring and piping before final assembly, streamlining the manufacturing process. Despite these innovations, the early Mustang had a critical flaw. Powered by the Allison V1710 engine, its performance fell off dramatically above 15,000 feet, precisely where the bombing campaign needed to be fought. The Mustang was relegated to low-altitude reconnaissance missions by the RAF, and it might have remained a footnote in aviation history were it not for what would prove to be one of the most significant modifications in the history of military aircraft. The Merlin transformation. British test pilot Ronald Harker was the first to recognize the untapped potential in the Mustang airframe. After flying an Allison-powered Mustang in April 1942, he wrote in his flight report, "The aircraft is a very fine fighter, marred by the use of an engine designed for other purposes." He then made a revolutionary suggestion. This aircraft could be the answer to our problems if it were fitted with a Rolls-Royce Merlin 61. The Merlin 61 featured a 2-speed, 2-stage supercharger designed by Stanley Hooker of Rolls-Royce. Unlike the Allison, which lost power at high altitudes, the Merlin maintained its performance in the thin air where bomber formations operated. While both engines produced around 1,570 horsepower at low altitude, the critical difference was that the Merlin could still deliver 390 horsepower at 23,500 feet compared to the Allison's 150 horsepower at just 11,800 feet. The British were quick to test the concept. At the Rolls-Royce facility in Hucknall, 5 Mustangs were converted to use the Merlin engine, creating what was known as the Mustang X. The results were spectacular. The Merlin-powered Mustang could reach 440 mph at high altitude, outpacing the Spitfire and leaving German fighters behind. The performance improvement was not merely incremental, it was transformative. The Mustang went from being outclassed at high altitude to dominating it. This transformation created an aircraft with an unprecedented combination of range and performance, 2 qualities that had previously been considered mutually exclusive in fighter design. High-performance fighters typically sacrificed fuel capacity for speed and agility, while long-range aircraft compromised combat capability for endurance. The Merlin Mustang broke this paradigm, combining both attributes in a single airframe. Across the Atlantic, the Americans were initially slow to embrace this transformation. The U.S. Army Air Forces had little interest in what they considered a foreign design. As one American liaison officer in Britain noted with frustration, the Mustang was sired by the English out of an American mother, and thus had no parent in the Army Air Corps to appreciate and push its good points. Nevertheless, the performance data couldn't be ignored. In July 1942, the USAAF contracted North American Aviation to build 2 prototype Merlin-powered Mustangs, designated XP-51B. The American version would use the Packard V1650E3, a license-built version of the Merlin 61, produced in the United States to ensure adequate supply. Converting the Mustang to use the Merlin wasn't a simple task. The new engine was over 350 pounds heavier than the Allison, requiring the wing to be moved slightly forward to maintain the aircraft's center of gravity. The cooling system had to be redesigned to handle the Merlin's different requirements. Despite these challenges, the first flight of the P-51B in November 1942 confirmed the British findings. The marriage of the Mustang airframe with the Merlin engine had created something extraordinary. The USAAF, now convinced of the Mustang's potential, moved with remarkable speed. In August 1942, months before the prototype even flew, they placed an order for 400 P-51B aircraft. Production began at North American's Inglewood, California plant in June 1943. The first Merlin Mustangs reached the European theater in late 1943, just in time to influence the critical air battles over Germany. The Luftwaffe's false security. To understand the shock that rippled through the Luftwaffe when Mustangs appeared over Berlin, we need to grasp the strategic situation from the German perspective. By 1943, the Luftwaffe had developed a sophisticated defense system for protecting German airspace. The chief of German fighters, Adolf Galland, had implemented a system of fighter control zones that coordinated radar detection, ground controllers, and fighter squadrons into an integrated defense network. The system's effectiveness depended on a key calculation: the known range limitations of Allied fighters. German planners had precisely mapped the distances at which each type of American fighter would be forced to turn back. Beyond these lines, bomber formations would be unescorted and vulnerable. German fighters could then concentrate their forces in these free hunting zones without having to worry about Allied fighter interference. This certainty was embedded in Luftwaffe doctrine and training. Pilots were taught exactly where they could expect to encounter Allied fighters and where they would be operating unopposed. German tactical manuals from the period show precise maps with concentric circles around Allied bases, indicating the maximum range of different fighter types. The P-47 Thunderbolt, P-38 Lightning, and early British fighters all had well-documented operational radii that the Germans had observed and verified through combat experience. For years, this mathematical certainty had given Luftwaffe pilots a deadly advantage. They could wait until the American escorts turned back, then swarm the unprotected bomber formations. Major Heinz Baer, a Luftwaffe ace with 2 on 20 victories, explained their tactics. We would climb above the bomber stream, out of sight, and wait for the signal that the American fighters had reached their limit and turned back. Then we would attack in mass formations, focusing on one box of bombers at a time. This tactic had proven devastatingly effective. During the second Schweinfurt raid on October 14, 1943, known to American airmen as Black Thursday, 60 of 291 B-17s were shot down, with another 17 damaged beyond repair. That represented a loss rate of 26% for a single mission. As winter approached, the 8th Air Force was forced to suspend deep penetration raids into Germany. The Luftwaffe seemed to have won a decisive victory. German confidence was further bolstered by their analysis of American aircraft production capabilities. Intelligence reports indicated that while America was producing impressive numbers of bombers, fighter production was limited. The Germans calculated that the Americans could not sustain high losses in both bombers and fighters simultaneously. This assessment led Luftwaffe commanders to believe that the Americans would eventually be forced to abandon daylight bombing altogether, as the British had done earlier in the war. Imagine, then, the disbelief among German pilots when, in late 1943, they began encountering American fighters hundreds of miles beyond their calculated range limits. At first, they assumed these were isolated incidents, perhaps a few P-47s that had pushed their fuel reserves dangerously low on one-way missions. But as the encounters multiplied, a disturbing reality dawned on the Luftwaffe. The Americans had somehow solved the range problem. The pilots' experience to understand the revolutionary impact of the P-51, we must consider the human experience of the pilots who flew it. 23-year-old Lieutenant Don Gentile of the 4th Fighter Group had flown the P-47 Thunderbolt for months before transitioning to the Mustang in early 1944. The difference, he later wrote, was like trading in a truck for a sports car. The P-51 was lighter, more responsive, and crucially had nearly twice the range of the P-47. Gentile described his first long-range mission in a P-51. We took off from England, escorted the bombers all the way to Berlin, mixed it up with 109s for 20 minutes, and flew all the way home with fuel to spare. In the P-47, we would have run dry somewhere, over the North Sea. It was a game-changer. We could now take the fight to the enemy anywhere in Europe. The P-51's tremendous range came from several sources. Its aerodynamic efficiency meant it burned less fuel cruising to the target. Its internal fuel capacity had been increased with the addition of an 85-gallon tank behind the pilot. And with external drop tanks, the Mustang could carry 489 gallons of fuel, enough for a combat radius of over 850 miles. For the first time, American fighters could escort bombers anywhere in the Reich. The tactical flexibility this range provided was revolutionary. Captain Clarence "Bud" Anderson of the 357th Fighter Group explained, "With the P-47, we had to constantly watch our fuel gauges. Every combat maneuver, every minute spent at high power, meant less fuel for the return journey. It was like fighting with one eye on the enemy and one eye on the fuel gauge. With the Mustang, we could focus entirely on the enemy." The psychological freedom that gave us was as important as the tactical advantages. This psychological aspect cannot be overstated. Pilots who know they have ample fuel reserves fight differently than those operating at the edge of their range. They are more aggressive, more willing to pursue enemies, and less likely to break off engagements prematurely. As Anderson put it, in a P-51 we owned the sky. We could go anywhere, stay as long as we wanted, and dictate the terms of combat. That's a powerful advantage. On the German side, the experience was one of growing dismay. Oberleutnant Erwin Leikoff of Jagdgeschwader 11 recalled his first encounter with Mustangs over central Germany in February 1944. "We were climbing to attack a bomber formation when our controller warned of enemy fighters nearby. We had been told this was impossible. We were 500 kilometers from England. When the Mustangs hit us, we lost 7 planes in minutes. It was a shock from which we never fully recovered." The Mustang's impact went beyond its range. Its performance at high altitude gave American pilots a crucial edge. At 30,000 feet, where bomber combat typically occurred, the P-51D could reach 440 mph, making it faster than both the Bf-109G, 4 mph, and the FW-190A 395 mph at that altitude. The Mustang could dive faster than its German opponents and, crucially, could sustain high-speed maneuvers without losing energy. Luftwaffe pilot Hans Meckel described the frustration of fighting against Mustangs. The P-51 would zoom past you so quickly you barely had time to register it was there. Then, when you tried to follow it in a dive, your 109 would start buffeting violently while the Mustang just pulled away. When you tried to climb back up, the Mustang would be waiting for you, diving again from above. It was like fighting a ghost that could appear anywhere. Captain Clarence "Bud" Anderson of the 357th Fighter Group described the Mustang's combat advantages. "In the P-51, we could choose when and how to fight. If we saw Messerschmitts below us, we could dive down, make a firing pass, and zoom back up to safety. The Germans couldn't follow us back up. Their planes didn't have the energy retention. We controlled the vertical battlefield, engineering excellence. The P-51's success wasn't just about its Merlin engine and long range. Every aspect of the aircraft had been engineered for peak performance. The airframe was exceptionally clean aerodynamically, crucial for both speed and fuel efficiency. The laminar flow wing, developed through extensive wind tunnel testing, reduced drag dramatically compared to conventional airfoils. The Mustang's armament was optimized for air-to-air combat. The 650 caliber Browning machine guns, with 1,080 rounds of ammunition, provided a lethal cone of fire. While German fighters often carried heavier 20mm or 30mm cannon, the Mustang's weapons offered a higher rate of fire and greater accuracy. In the hands of a skilled pilot, the P-51's armament was more than sufficient to destroy any enemy aircraft. North American aviation engineer Edgar Schmood, the Mustang's chief designer, later revealed that the aircraft's exceptional handling characteristics weren't accidental. "We designed the Mustang to be both stable and responsive," he explained. "It needed to be a steady gun platform for accurate shooting, but also agile enough for dogfighting. Achieving that balance was perhaps our greatest success." This balance of qualities made the P-51 forgiving for new pilots, yet rewarding for experts. Unlike some high-performance fighters that were difficult to fly, the Mustang was relatively easy to handle. It had no vicious stall characteristics, responded predictably to control inputs, and was stable in all flight regimes. This meant that even relatively inexperienced pilots could fly it effectively in combat, while veterans could exploit its full performance envelope. The aircraft's cockpit ergonomics also contributed to its effectiveness. The bubble canopy introduced on the P-51D provided outstanding visibility in all directions, critical for spotting enemy aircraft. The control layout was intuitive, allowing pilots to operate the aircraft without having to hunt for switches or gauges. These seemingly minor details had major implications in combat, where split-second reactions often determined survival. Major Jack Ilfrey, an 8-victory ace with the 79th Fighter Squadron, noted, "The Mustang felt like it was built around the pilot. Everything was where you expected it to be. You didn't have to think about flying the airplane. You just thought about fighting the enemy. That's the hallmark of a great fighter design." Strategic revolution. The arrival of the P-51 in substantial numbers coincided with a revolutionary change in fighter tactics. Major General James Doolittle, who took command of the 8th Air Force in January 1944, recognized that the Mustang's capabilities offered an opportunity to fundamentally change the air war. Previously, American fighters had been required to stay close to the bomber formations they were protecting, essentially flying in defensive circles around the bombers. This tactic, while providing some security for the bombers, allowed the Luftwaffe to choose when and where to attack. Doolittle had the strategic vision to see that the P-51's range and performance allowed for a more aggressive approach. In a directive that would transform the air war, Doolittle declared, "The first duty of the 8th Air Force fighters is to destroy German fighters." Rather than keeping escorts tied to the bombers, he unleashed them to seek out and destroy the Luftwaffe wherever it could be found. This shift from defensive to offensive fighter operations was revolutionary, changing the fundamental dynamic of the air war. This new strategy had profound implications. Rather than reacting to German attacks, American fighters would now take the initiative, forcing the Luftwaffe to defend itself instead of focusing on the bombers. The psychological impact on both sides was immediate. American pilots, freed from the constraints of close escort, could exploit their aircraft's capabilities to the fullest. German pilots, accustomed to facing bombers with minimal fighter opposition, now found themselves under constant threat from marauding Mustangs. The implementation of this strategy required careful planning and coordination. The 8th Air Force developed a layered escort system that provided continuous coverage for bomber formations while still allowing fighters to seek out the enemy. Fast-climbing P-47 Thunderbolts would take off first, providing initial escort for the bomber stream. As the formation approached German territory, Mustangs would take over, accompanying the bombers all the way to the target and back. This system allowed each fighter type to operate where it was most effective. P-47s, with their excellent high-altitude performance but limited range, could protect the bombers during the initial and final stages of the mission. P-51s, with their superior range, could provide escort deep into enemy territory. The result was a seamless protective umbrella that left no gaps for the Luftwaffe to exploit. The results were dramatic and immediate. During Big Week in February 1944, the 8th Air Force launched Operation Argument, a series of massive raids against German aircraft factories. With Mustangs now providing escort all the way to the targets and back, bomber losses dropped dramatically while Luftwaffe casualties soared. In just 6 days, the Germans lost 355 fighters and, more critically, 400 irreplaceable experienced pilots. Major James Howard, flying a P-51B named Ding Hao, very good in Chinese, provided a striking example of what a single Mustang could accomplish during the Oschersleben raid on January 11, 1944. When his fighter group became separated from the bomber formation they were escorting, Howard found himself alone protecting a box of B-17s under attack by approximately 30 German fighters. Rather than retreating, Howard single-handedly engaged the entire German formation, shooting down 3 enemy aircraft confirmed and 3 more probable, while driving the rest away from the bombers. For this extraordinary act, Howard was awarded the Medal of Honor, the only fighter pilot in the European theater to receive the nation's highest decoration. Howard's citation read in part, "Quickly breaking up the enemy's formation and destroying 1 fighter, he immediately turned toward the second group of 30-plus enemy fighters. Striking the enemy with lightning speed, he destroyed 1 German fighter and forced the other enemy fighters to break up their formation." His demeanor was so cool, his skill so extraordinary, that the bomber crews, already quite occupied with their own defense, took time to cheer him on. Howard's feat was exceptional, but it exemplified the new aggressive spirit that the P-51 made possible. With their superior aircraft, American pilots could now take on multiple opponents and prevail through a combination of performance advantage and tactical skill. The psychological impact of such encounters on German pilots was devastating. The sense that they could be attacked anywhere, anytime, even when they had numerical superiority. The hunting begins with Doolittle's new directive. Mustang pilots became hunters rather than guardians. On April 15, 1944, the 8th Air Force launched Operation Jackpot, sending Mustangs on free hunting sweeps targeting Luftwaffe airfields. This aggressive new tactic caught the Germans completely by surprise. Colonel Hubert "Hub" Zemke, commander of the 56th Fighter Group, described the strategy. "We would send formations of Mustangs at minimum altitude, sometimes as low as 50 feet, to avoid radar detection. We'd pop up over German airfields just as their fighters were taking off or landing when they were most vulnerable." The effect was devastating. These airfield attacks, known as strafing missions, were incredibly dangerous. Flying at high speed just above the ground, pilots faced threats from light flak, machine gun fire, and even small arms. A single hit to the Mustang's liquid-cooled engine could be fatal. Yet the tactical advantage was worth the risk. By destroying aircraft on the ground, American pilots could eliminate enemy fighters without giving their pilots a chance to fight back. Major George Preddy, flying his P-51D Cripes a Mighty, described a typical strafing mission. "We came in at treetop level, too low for their radar to pick us up. The first pass was always the most effective. They didn't know we were coming until we were already shooting. I hit a row of 109s parked wingtip to wingtip. The first one exploded, then the second. The third pilot was running toward his plane when my tracers caught him. I still see his face in my dreams, sometimes." The numbers tell the story. In a single day, Preddy destroyed 6 German aircraft on the ground at Prague Airfield. Captain Don Gentile, known as the One-Man Air Force, destroyed 15 enemy aircraft in just 3 months, flying the P-51. By the end of the war, Mustang pilots had claimed 4,150 enemy aircraft shot down, about half of all USAAF claims in the European theater. Even more tellingly, P-51 pilots destroyed 431 enemy aircraft on the ground, a statistic that reflects the offensive hunting strategy made possible by the Mustangs' capabilities. These airfield attacks forced the Luftwaffe to disperse their fighter forces to smaller, more distant fields, complicating their already strained operations. Fuel shortages, exacerbated by Allied bombing of synthetic oil plants, meant German pilots received far less training than their American counterparts. While a new American pilot might have 400 hours of flight time before entering combat, German replacements by 1944 often had less than 120 hours, a critical disadvantage in aerial warfare. The psychological impact of these strafing attacks was profound. German airfields, once considered secure rear areas, were now potential death traps. Pilots and ground crews lived in constant fear of Mustang attacks. Some Luftwaffe units resorted to building dummy aircraft and decoy airfields to draw American attacks away from their operational bases. Others dispersed their aircraft to forests and camouflaged them under trees. Effective for survival, but disastrous for maintenance and operational readiness. Lieutenant Colonel John Meyer, commander of the 487th Fighter Squadron, recalled, "By mid-1944, the Luftwaffe was running scared. Their pilots knew we could hit them anywhere, anytime. We had complete air superiority. It wasn't just a tactical advantage, it was psychological dominance. They were defending, we were attacking. In war, that's a decisive edge." The German response. The Luftwaffe did not surrender the skies without a fight. German engineers worked frantically to develop countermeasures against the Mustang threat. One response was the development of specialized bomber-destroyer units called Sturmgruppen. These formations consisted of heavily armored FW-190A8 fighters carrying multiple 20mm and 30mm cannons. Flying in tight formations, they would attempt to punch through the Mustang screen to reach the bomber formations. These FW-190A8R2 variants, known as Sturmbach battering ram, were formidable bomber killers. With armor plate protecting the engine and cockpit, and armed with two 20mm MG-151 cannon and two 30mm MK-108 cannon, they could bring down a B-17 with a short burst. However, these modifications came at a price. The additional weight reduced performance drastically. Top speed dropped to around 350 mph, and climb rate and maneuverability suffered accordingly. While occasionally effective, these specialized units were themselves vulnerable to the faster, more agile Mustangs. Luftwaffe. General Adolf Galland later wrote, "The appearance of the P-51 Mustang with its superior performance and range forced us to develop increasingly specialized aircraft types for different missions, fragmenting our fighter force at precisely the moment when we needed unified tactics." Another German response was the development of new fighter formations and tactics. The Gefechtsverband battle formation consisted of a Sturmgruppe of heavily armed FW-190s escorted by two Begleitgruppen, escort groups, of Bf-109s. The Bf-109s would engage the American fighters while the FW-190s attacked the bombers. In theory, this combination of specialized aircraft would exploit the strengths of each type while minimizing their weaknesses. In practice, these complex formations proved difficult to assemble and coordinate. The Gefechtsverband required precise timing and communication to be effective. American intelligence quickly identified these formations through radio intercepts, allowing Mustang groups to intercept them before they could reach the bomber streams. By the time the Germans could organize their complex defensive formations, American fighters were already waiting for them. The Germans also accelerated the development of jet aircraft, resulting in the revolutionary Messerschmitt Me 262, the world's first operational jet fighter. With a top speed of 540 mph, the Me 262 could outrun any Allied piston-engined fighter. But by the time it entered service in late 1944, fuel shortages, production problems, and Hitler's insistence on using it as a bomber rather than a fighter limited its impact. Luftwaffe pilot Hans Guido Muttke, who flew the Me 262 with Jagdgeschwader 7, recalled, "The Me 262 was a magnificent aircraft, 100 miles per hour faster than anything the Allies had. But we never had enough of them, never had enough fuel to train properly, and never had the chance to use them as they should have been used. When we did get airborne, we could outrun the Mustangs easily. But we had to land eventually, and they were always waiting for us. Even with their superior speed, Me-262s proved vulnerable to Mustangs during takeoff and landing. P-51 pilots developed tactics specifically for hunting jets, establishing patrol patterns around German jet bases to catch the Me-262s during their vulnerable transition phases. On October 7, 1944, Lieutenant Urban Drew of the 361st Fighter Group shot down 2 Me-262s that were taking off, demonstrating that even revolutionary technology could not overcome the strategic advantage the Mustangs had established. Drew described the encounter. "I saw 2 strange-looking aircraft taking off from an airfield below. They had no propellers. My first thought was that they were gliders. Then I realized they must be the new German jets we'd been briefed about. I dove down and caught the first one just as it lifted off. My first burst hit its left engine, and it cartwheeled off the runway. The second one was climbing away, but it was still slow. I closed to 300 yards and fired. Pieces flew off its right wing, and it rolled inverted and crashed. This pattern repeated itself throughout the final months of the war. The Germans developed increasingly advanced aircraft. The Me-262 jet fighter, the Me-163 Comet rocket-powered interceptor, and the TA-152 high-altitude fighter, but none could be produced in sufficient numbers or operated effectively enough to reverse the Mustangs' dominance of German airspace. Manufacturing might. The story of the P-51 is not just one of technical excellence, but also of American industrial power. By July 1944, North American aviation was producing Mustangs at the astonishing rate of 700 aircraft per month from factories in Inglewood, California, and Dallas, Texas. By the end of the war, more than 15,000 Mustangs of all variants had been built, a testament to America's unmatched production capacity. The Inglewood plant alone covered over 85 acres, employing more than 45,000 workers at its peak, many of them women entering the industrial workforce for the first time as part of the Rosie the Riveter movement. The factory operated around the clock with 3 shifts working 7 days a week. At the height of production, a new Mustang rolled off the assembly line every hour. This manufacturing prowess created an insurmountable numerical advantage. A captured German report from August 1944 noted with despair, "When we shoot down an American fighter, 3 more appear the next day. When we lose a fighter, it is irreplaceable." The stark mathematics of attrition was working inexorably against the Luftwaffe. The quality of American production was equally important. While German aircraft often featured superior engineering in some respects, American designs emphasized standardization, ease of maintenance, and reliability. A P-51 could be serviced in the field with basic tools, while German aircraft frequently required specialized equipment and highly trained mechanics. The Mustang's Packard-built Merlin engine was a model of reliability, typically operating for 400–500 hours between overhauls, far longer than its German counterparts. Chief Warrant Officer Joseph Stupka, a maintenance officer with the 352nd Fighter Group, recalled, "The P-51 was a mechanic's dream compared to earlier fighters. Everything was accessible, parts were interchangeable, and the systems were logically arranged. We could replace an entire engine in under 4 hours with a 6-man team. Try doing that with a P-47, let alone a German fighter." This combination of quality and quantity created an overwhelming advantage. By early 1945, American fighters outnumbered their German opponents by more than 10-1 in serviceable aircraft. On some days, the 8th Air Force could put more than 1,000 fighters into the air over Germany, while the entire Luftwaffe might field fewer than 300 operational aircraft on the Western Front. The decisive campaign. The summer and fall of 1944 marked the decisive phase of the air war over Europe. With Mustangs now providing escort throughout German airspace, the strategic bombing campaign finally began to achieve its intended results. The most significant target was the German synthetic oil industry, which produced the fuel necessary for the Wehrmacht's tanks, trucks, and aircraft. On May 12, 1944, the 8th Air Force launched the first major attack against oil targets, striking plants at Luna, Brucks, and Zeitz. Escorted by P-51s, the bomber force destroyed approximately 50% of Germany's synthetic oil production in a single day. Unlike factories, which could be dispersed and hardened against bombing, the massive chemical plants necessary for synthetic oil production remained vulnerable. The impact was immediate and severe. In June 1944, the Luftwaffe received only 30% of its fuel allocation, barely enough to maintain minimal training operations, let alone sustain an effective defense. By September, fuel shortages had become so acute that many German fighter units could fly only 2 or 3 days per month. Some pilots were sent into combat with less than 50 flight hours in their aircraft, a virtual death sentence against experienced American pilots with hundreds of hours of flight time. The 8th Air Force's daily operational summaries tell the story. An entry from August 1944 notes, "Enemy fighter opposition continues to decline. Today's mission to oil targets in central Germany encountered only sporadic resistance." Mustang groups report destroying 32 enemy aircraft in the air and 47 on the ground, for the loss of 7 P-51s. Bomber losses were 12 from a force of 672, less than 2%. The decisive moment that demonstrated the Mustangs' domination came during the Allied invasion of Normandy in June 1944. The Luftwaffe was almost entirely absent from the skies over the beaches. Allied air supremacy, achieved largely through the efforts of Mustang fighter groups, had reduced German air opposition to negligible levels. A German Luftwaffe report from that period, captured after the war, stated simply, "Fighter units are no longer capable of fulfilling their primary mission of air defense due to constant attrition and fuel shortages." What perhaps most underscores the Mustangs' impact was a statement attributed to Reichsmarschall Hermann Göring, commander of the Luftwaffe. When informed that American fighters had been seen over Berlin, he reportedly said, "When I saw Mustangs over Berlin, I knew the jig was up." While this quote has been debated by historians, it captures the psychological impact of the P-51's range and capabilities on German leadership. By late 1944, Mustang pilots were conducting missions that would have been unimaginable just a year earlier. On November 2, 1944, Colonel John Meyer led the 352nd Fighter Group on a mission to Merseburg, deep in central Germany. After escorting bombers to the target, Meyer's Mustangs swept the area, strafed 2 airfields, shot down 8 aircraft in the air, and destroyed 21 on the ground, all without a single loss. Meyer himself accounted for 2 aerial victories and 5 ground kills. After the mission, Meyer wrote in his combat report, "Today's operation demonstrated complete air superiority. We were able to operate with impunity throughout the target area. Enemy aircraft avoided combat when possible, and their defensive fire from ground installations was sporadic and inaccurate. It is evident that fuel shortages and personnel losses have severely degraded the Luftwaffe's combat effectiveness." The human factor. Beyond technical specifications and production numbers, the P-51's success stemmed from the quality of the pilots who flew it. The American training system produced highly skilled aviators with substantial flight time before they ever faced combat. By 1944, the average American fighter pilot had 400 hours of flight training, compared to less than 200 for his German counterpart. The 332nd Fighter Group, known as the Red Tails for the distinctive markings on their P-51s, provides a powerful example of the human excellence behind the Mustang's success. Composed entirely of African-American pilots who had overcome both institutional racism and technical challenges to earn their wings, the 332nd compiled an outstanding combat record. Flying P-51s, They never lost a bomber to enemy fighters on any of their escort missions, a unique achievement among fighter groups. Colonel Benjamin O. Davis, Jr., commander of the 392nd, understood that his men carried a double burden, fighting both the enemy abroad and prejudice at home. He instilled in his pilots a disciplined approach to escort duty, emphasizing that their primary mission was bomber protection rather than scoring personal victories. This disciplined approach paid dividends in the group's exceptional record of bomber protection. Captain Roscoe Brown, a pilot with the 302nd, recalled, "Colonel Davis made it clear that our success or failure would impact opportunities for all African Americans in the military. We couldn't just be as good as other fighter groups, we had to be better. In the P-51, we had an aircraft that allowed us to demonstrate our skills on equal terms. The combination of our determination and the Mustang's capabilities made us exceptionally effective escorts. The experience of combat in a P-51 was transformative for pilots. Lieutenant Chuck Yeager, who would later break the sound barrier, described his first victory in a Mustang. I was escorting B-17s to Berlin when I spotted a Messerschmitt 109 below us. I rolled over and dove, quickly closing the range. The Mustang was so stable that I had no trouble lining up my shot. I fired a short burst and saw strikes all along his fuselage. He rolled over and went straight in. What amazed me was how the Mustang handled the dive and recovery. It felt like the airplane was an extension of my body. By the end of the war, 275 American pilots had become aces flying the P-51, meaning they had shot down 5 or more enemy aircraft. The leading Mustang ace, Major George Preddy, scored 26.83 victories before he was tragically killed by friendly fire on Christmas Day 1944. The numbers tell an impressive story, but perhaps more telling was the confidence American pilots felt in their aircraft, a psychological edge that proved decisive in combat. The human stories behind these statistics reveal the bond between pilots and their machines. Captain William Wisner of the 352nd Fighter Group became an ace in a single mission on November 21, 1944, shooting down 5 FW-190s while flying his P-51D Moonbeam McSwine. After landing, Wisner patted his aircraft's fuselage and told his crew chief, "She's not just a machine, she's the other half of a team. Take care of her, and she'll take care of me." This sentiment was echoed by countless Mustang pilots. They developed deep attachments to their aircraft, personalizing them with names, nose art, and custom modifications. These were not merely expressions of individuality, they reflected the intimate connection between pilot and machine that developed in combat. A fighter pilot's survival depended on knowing his aircraft's capabilities and limitations to the fullest extent. The P-51's forgiving handling characteristics and exceptional performance inspired confidence that translated directly into combat effectiveness. Innovation continues. The P-51D, which entered service in early 1944, represented the definitive Mustang variant. It featured a bubble canopy that eliminated the rear fuselage spine of earlier models, giving pilots a 360-degree view, a crucial advantage in air combat, where situational awareness often meant the difference between victory and death. The D model also standardized the armament to 650 caliber machine guns with 1,840 rounds of ammunition. The bubble canopy was a direct response to combat experience. Pilots of earlier P-51B and C models complained about the restricted visibility to the rear, a dangerous blind spot in aerial combat. North American engineers solved this problem by adopting the British-designed teardrop canopy, which required a complete redesign of the rear fuselage. Despite the significant changes required, the new canopy was incorporated into production within months of the first combat reports, another example of the rapid innovation cycle that characterized American aircraft development. Even as the P-51D was proving itself in combat, American engineers continued to refine the design. The P-51H, which began reaching units in early 1945, was a thoroughly redesigned aircraft that managed to be both lighter and more powerful than the D model. With a top speed of 487 mph, it was the fastest Mustang variant and one of the fastest piston-engine fighters ever built. However, with the war clearly winding down, only 555 P-51Hs were produced before VE Day. The P-51H achieved its superior performance through extensive use of light alloys and structural redesign. Engineers shaved nearly 600 pounds from the airframe while maintaining structural integrity. The H model used a more powerful version of the Merlin engine, the V1959, producing 2,218 horsepower with water injection. These improvements gave it a climb rate 29% better than the P-51D and a top speed 39 mph faster. Had the war continued, the P-51H would have represented a significant leap in combat capability. The continued evolution of the Mustang demonstrated the American approach to weapons development, a pragmatic combination of scientific research, feedback from operational units, and rapid implementation of improvements. Each new variant incorporated lessons learned from combat experience, creating a continuous cycle of improvement. This approach contrasted sharply with German aircraft development, which often pursued revolutionary technologies at the expense of refining existing designs. While Germany produced impressive experimental aircraft like the Me-262 jet fighter, it failed to maintain the quality and performance of its standard fighters like the Bf-109 and Fw-190. The result was a Luftwaffe equipped with a mix of obsolescent standard fighters and advanced types too few in number to affect the strategic balance. The Pacific Theater. While the Mustang's greatest impact was in Europe, P-51s also served with distinction in the Pacific Theater. Beginning in 1944, Mustangs operated in China, Burma, and eventually from Iwo Jima against the Japanese home islands. The P-51's long range proved equally valuable in the vast Pacific, where distances between islands could stretch hundreds of miles. In China, Mustangs flown by the 23rd Fighter Group, the famous Flying Tigers, proved superior to the most advanced Japanese fighters, including the Nakajima Ki-84 Hayate. Major John Allison, who flew both P-40s and P-51s in China, noted, "The P-40 could hold its own against Japanese fighters in a turning fight, but the Mustang could outperform them in every dimension: speed, climb, and dive. It completely outclassed anything the Japanese had." The 23rd Fighter Group's transition from the P-40 to the P-51 dramatically increased its effectiveness. In the 6 months before receiving Mustangs, the group claimed 100 Japanese aircraft destroyed. In the 6 months after transitioning to the P-51, they claimed over 250, a 150% increase in combat effectiveness. These numbers reflect not just the P-51's superior performance, but also its greater range, which allowed pilots to seek out Japanese aircraft rather than waiting for them to appear over American bases. After the capture of Iwo Jima in March 1945, P-51s of the 7th Fighter Command began escorting B-29 Superfortress bombers on raids against Japan. On April 7, 1945, 108 P-51s flew their first very long-range mission to Tokyo, a round trip of 1,500 miles from Iwo Jima. The presence of Mustang escorts forced Japanese defenders to focus on the fighters rather than concentrating on the bombers, significantly reducing B-29 losses. Major James Tapp, who led one of the first Mustang missions from Iwo Jima, recalled, "We knew we were making history. No fighter had ever operated at such ranges before. We took off from an island that was still an active combat zone. You could hear artillery fire as we climbed out. 8 hours later, we were over Tokyo, mixing it up with Japanese fighters. Then another 4-hour flight back to Iwo. The Mustang's range made it all possible." These long-range missions pushed both aircraft and pilots to their limits. Flying over open ocean for hours, navigating by dead reckoning, and then engaging in combat required exceptional skill and endurance. The P-51's reliability was critical. Engine failure over the Pacific meant almost certain death. Yet the Mustang proved equal to the challenge, maintaining impressive serviceability rates despite the harsh conditions of forward island bases. The Pacific experience demonstrated that the P-51's combination of range, speed, and combat effectiveness was not theater-specific but represented a fundamental advance in fighter capability that could be applied worldwide. By the time of Japan's surrender in August 1945, the Mustang had established itself as the premier fighter aircraft of World War II in both European and Pacific operations. Legacy and influence. The P-51 Mustang's influence extended far beyond World War II. It served with distinction in the Korean War beginning in 1950, where it was redesignated F-51 under the new Air Force naming convention. While jet fighters like the F-80 Shooting Star and F-86 Sabre eventually took over air superiority missions, the Mustang remained valuable as a ground attack aircraft due to its long range and durability. In Korea, Mustangs typically carried bombs, rockets, and napalm for close air support missions, providing crucial assistance to ground troops. Major Louis J. Sabile posthumously received the Medal of Honor after deliberately crashing his damaged F-51 into an enemy position during the Battle of Pusan Perimeter in August 1950, demonstrating the continued courage of Mustang pilots in a new war. The Mustang's international legacy was equally significant. After World War II, P-51s were supplied to more than 25 nations worldwide, from Sweden to South Africa, Australia to Uruguay. In some air forces, Mustangs remained in service into the 1980s, an extraordinary testament to the durability and effectiveness of the original design. The final military Mustangs were retired by the Dominican Air Force in 1984, more than 40 years after the type's combat debut. The last combat use of the P-51 occurred during the 1969 Football War between El Salvador and Honduras, where Salvadoran Mustangs engaged Honduran aircraft in the last known air-to-air combats between piston-engined fighters. Even in this twilight role, the Mustang's performance and reliability remained impressive, a testament to the fundamental soundness of its design. The Mustang's legacy lives on in modern fighter design. Its emphasis on range, performance, and adaptability established principles that continue to influence military aircraft development. Modern fighters like the F-15 Eagle, while vastly more sophisticated, follow the same fundamental philosophy that guided the P-51's development, the pursuit of air superiority through a balanced combination of speed, range, firepower, and maneuverability. Perhaps the most enduring legacy of the P-51 is found in the hundreds of restored Mustangs that continue to fly today at air shows around the world. The distinctive sound of a Merlin engine at full throttle still draws crowds of admirers, connecting new generations to this remarkable chapter in aviation history. These flying memorials testify to the excellence of the original design and the lasting impact it had on the course of history. In 2020, the United States Air Force honored this legacy by naming its newest fighter the Next Generation Air Dominance Platform, continuing the tradition of air superiority that the P-51 pioneered. While the specifics of this sixth-generation fighter remain classified, its mission echoes the fundamental purpose of the Mustang: to control the skies and ensure freedom of action for all other military operations. The final analysis. In my years studying military history, I've found few examples of a technical innovation so completely altering the strategic balance. The P-51 Mustang wasn't just another fighter. It represented a fundamental shift in aerial warfare. Its combination of range, speed, and combat effectiveness made possible what had previously seemed impossible: the defeat of the Luftwaffe in its own airspace. The story of the Mustang is, at its core, a testament to American ingenuity, industrial might, and fighting spirit. It demonstrates how technological innovation, when properly applied, can have strategic consequences far beyond tactical advantages. The transformation of the mediocre Allison-powered P-51 into the world-beating Merlin Mustang represents one of the most significant engineering achievements of World War II. By May 1945, the Luftwaffe was a broken force. Fuel shortages, loss of experienced pilots, and the relentless pressure from Mustang fighter sweeps had reduced German air power to a shadow of its former self. Even the introduction of revolutionary jet fighters like the Me-262, technically superior to any Allied piston-engined fighter, could not reverse the tide. Mustang pilots quickly developed tactics for catching the jets during their vulnerable takeoff and landing phases. The numbers tell the story of Mustang dominance. By VE Day in May 1945, P-51 pilots had claimed 4,050 enemy aircraft destroyed. Of these, 4,031 were destroyed on the ground. These figures represent about half of all USAAF air-to-air victory claims in the European theater. The transformation was complete, from a fighter once considered inadequate for high-altitude combat to the dominant air superiority weapon of the war. The P-51 Mustang didn't win World War II by itself. No single weapon could achieve that. But it made possible the daylight strategic bombing campaign that crippled German industry. It broke the back of the Luftwaffe, allowing Allied armies to advance across Europe without significant air opposition. And, perhaps most importantly, it saved the lives of thousands of American bomber crewmen who would otherwise have fallen victim to German defenses. Today, more than 75 years later, the distinctive shape of the P-51 Mustang remains instantly recognizable, an enduring symbol of the time when American engineering and courage combined to achieve what had once been considered impossible: complete dominance of the skies over Nazi Germany. The lessons learned from this remarkable aircraft continue to influence military aviation to this day, a lasting legacy of one of history's most successful fighter designs. When Mustangs first appeared over Berlin, they signaled the beginning of the end for the Luftwaffe and, ultimately, for Nazi Germany itself. The shock and disbelief among German pilots upon seeing American fighters so deep over the Reich was more than just tactical surprise. It was the realization that the technological advantage had shifted decisively, and with it, the entire strategic balance of the air war. The impossible had become possible, and the course of history would never be the same.